Okay, so today we're looking at section 4.1, which is called the area problem. We're going to find the area under curves using rectangles. Okay, so the first way to find an area under the curve is to use your left endpoints. This is also called using your lower estimates. So if it asks you to find your lower estimates, it's asking you to use your left endpoints, which is where you draw rectangles starting with your furthest left value. It's called your lower estimate because typically if you're using your left values, all of your rectangles are underneath of your curve. Okay, the other way to find your area under your curve using rectangles is to use your right endpoints, which is where you draw a triangle starting with your furthest right value. And that's called your upper estimate because typically your rectangles are above the curve. And then your goal in finding your upper limits and your lower limits is that if you have values that are slightly above the graph and values that are slightly below the graph, if you average them, you'll get a fairly accurate representation of the area under your graph. So if I look at example 1, it tells me to use rectangles to estimate the area under the curve of y equals x squared from 0 to 1 using 4 rectangles. And then it wants us to average the upper and lower estimates to get an approximate area. Okay, so my kind of key information there tells me that I'm going to use the graph x squared. I'm only looking at values from 0 to 1, and I'm using 4 rectangles to do it. Okay, so since I'm only using the areas from 0 to 1, I'm just going to stick with just my first quadrant. So I'm going to put 0 here, and I'm going to put 1 over here. And then I know that if I plug that in, 0 squared is 0. 1 squared is 1. So if I zoomed in on my x squared graph only for those two values, my graph would look like that. Then it tells us to use 4 rectangles. So that tells me that I'm going to split 0 to 1 into 4 pieces. So 1/4, 1/2, and 3/4. You take whatever your last value is your graph that you care about. So in this case it's 1, and then you divide it by the number of rectangles that you need. So now I get to find my upper and lower estimates. If I start with my lower estimates, I'll do my lower estimates in green. I start at my furthest left value. So my furthest left value in this case is 0. So I'm going to have a rectangle from 0 to 1/4. Then I'm going to have a rectangle from 1/4 to 1/2. From 1/2 to 3/4. And from 3/4 up to 1. And if I want to find my heights of my rectangle at these points, I know that 1/4 squared is 1/16. I know that 1/2 squared is 1/4. I know that 3/4 squared is 9/16. So those are the heights of my rectangles. Okay. So if I want to find the area of this first rectangle, I know I have a height of 0 and a length of 1/4. So the area of my first rectangle is just 0. If I go to my second rectangle, I have a height of 1/16 and a length of 1/4. So I would have 1/16 times 1/4 for my second rectangle. For my third rectangle, I have a height of 1/4 and a length of 1/4. And for my last rectangle, I have a height of 9/16 and a length of 1/4. Okay, so if I go to find those, 1 times 1 is 1, 16 times 4 is 64. 1 times 1 is 1, 4 times 4 is 16, and 9 times 1 is 9, 16 times 4 is 64. In order to add these fractions, you have to have common denominators. So if I take this side times 4, then this fraction actually becomes 4 over 64. So I get 1 plus 4 plus 9, which gives me 14. I could reduce it, but I'll just leave it as 14 over 64. Okay, so that tells me the area under my curve for my lower estimates is 14 divided by 64. Now if I want to find my upper estimates, I'm going to do the same thing, except I'm going to start with my furthest right value. So my furthest right value then is 1, because that's my last value. And I'm going to do the same thing. I'm going to go back. So from 1 to 3/4, I'm going to have a rectangle. Then from this point, right where it hits the curve at 3/4, I'm going to go back and have another rectangle. At 1/2, right where it hits the curve, I'm going to go back and have my third rectangle. And then finally at 1/4 where it hits the curve, I'm going to go back and have my last rectangle. So most of the heights of my rectangles are already found. The only one I didn't find was this one, which we know 1 squared is 1. So the height of that rectangle is 1. So if I go to find my upper estimates, if I find the area of this first triangle on the left, I know that I have a length of 1/4 and a height of 1/16. So 1/16 times 1/4. If I go to find the second rectangle, I have a length of 1/4 and a height of 1/4. My third rectangle, I have a length of 1/4 and a height of 9/16. And for my last rectangle, I have a length of 1/4 and a height of 1. So if I multiply those out, 1/16 times 1/4 is 1/64. 1/4 times 1/4 is 1/16. 9/16 times 1/4 is 9/64. And 1 times 1/4 is just 1/4. Since I need these to have common denominators to add them, I'm going to multiply the 1/16 by 4 and the 1/4 by 16. Meaning that 1/16 actually becomes 4/64. And 1/4 becomes 16/64. So in adding them up, then I know my denominator is 64 again. If I add the tops, 1 plus 4 is 5, plus 9 is 14, plus 16 is 30. So my upper estimates give me an area of 30 over 64, which I can reduce, but I'll just leave it. And the last thing it asked us to find was the average, so that we would be able to best estimate the area under the curve. So to find an average, you just add up your values and divide by the number. So 14/64 plus 30/64 divided by 2. 14/64 plus 30/64 gives me 44/64. And dividing by 2 is the same thing as multiplying by 1/2. So if then I multiply those two fractions, 44 times 1 is 44. 64 times 2 is 128. So the best estimate of the area under the curve would be 44 divided by 128. Okay, so any questions on the first one? Okay, so let's do another one. So I'm asked to use rectangles to estimate the area under the curve of y equals cosine of x from 0 to pi over 2 using 4 rectangles. And I'm going to average the upper and lower estimates to get an approximate area. Alright, so again, we're going from 0 to pi over 2, so I only care about my positive values on my graph. If I put pi over 2 out here, 0 is right there, and then I start actually graphing cosine of x. So I know cosine of 0 is 1. Then if I'm going to use 4 rectangles, I need to divide this by 4, which means pi over 8 is going to be my pieces. pi over 4 and 3 pi over 8. Okay, well, if we know what our pi graph does, we know that our pi graph goes down, down, up, up. So there's my pi graph. So now if I want to find my lower estimates, I use my furthest left point, and I'm going to make rectangles. So my furthest left point is 0, and I'm going to make a rectangle from 0 to pi over 8. Then my next point is pi over 8 to pi over 4. Then pi over 4 to 3 pi over 8. And 3 pi over 8 to pi over 2. Okay. So I know my height at this rectangle is 1. I know my height at my second rectangle is -1, -1, and +1. Okay, so if I start with my first rectangle, I have a length of pi over 8 and a height of 1. With my second rectangle, I have the same length, pi over 8, with a height of -1. Third rectangle, I have a length of pi over 8, with a length of -1. And my last rectangle, I have a length of pi over 8, with a height of +1. Okay, so pi over 8 times 1 is just pi over 8. Pi over 8 times -1 is negative pi over 8. Pi over 8 times -1 is negative pi over 8. And pi over 8 times +1 is positive pi over 8. And so what becomes my area of my lower estimate then?
0.
0, yep, everything cancels. So the area under my curve for my lower estimates is 0. Okay, I do the same thing then for my upper estimates. I'll start with my furthest left point, which is 1, over 2 and 1. And I'm going to draw rectangles to match that area. Okay, well, what do you notice, I guess, about your upper estimate rectangles? As compared to your lower estimate rectangles. They're the same. Okay, so your upper estimate and your lower estimate rectangles end up being the same. So instead of going through all defining areas, I just know that then my upper estimate is also going to be equal to 0 because the rectangles ended up being the same. So then if I want you to average them, your average is 0. Your average exists. 0 plus 0 is 0. 0 divided by 2 is 0. Okay, how do we feel about finding area under curve? Good, bad, not good. Okay. Alright, you guys have a fairly short assignment today, 293, 1 through 8.